So this is a video on the Chapter 12 D-Day number 1. I'm just going to jot up here a couple of formulas or identities. Sine squared, x plus cosine squared x equals 1. If I was to divide everything by sine squared x, I would get a new one, which is 1 plus cotangent squared x is equal to cosecant squared x. If I would have taken that same equation and divided everything by cosine squared, I would have ended up with tangent squared x plus 1 is equal to secant squared x. So these are Pythagorean identities that you're going to be seeing some of this. So this one right here is going to help me with this one. So if I was to rewrite that by minusing 1 from both sides, so if I was to take this and minus 1 from both sides, so I'm going to get a sine squared x minus 1, and I take my cosine squared x to the other side, you see that my answer is negative cosine squared x. So this right here is equal to this. Those are the same. The tangent squared. So if I am using this one here, I see that this is going to be equal to secant squared x. That's your answer. Now 1 over cosecant. Cosecant and sine are reciprocals. So this would just be sine theta, because the cosecant is the reciprocal of sine. Okay, this cosecant squared 1. So I am going to be looking to this one here, okay? And so let me just jot that down here. So 1 plus cotangent squared x is equal to cosecant squared x, okay? And so I am going to minus 1 from both sides. So I'm going to get cotangent squared x is equal to cosecant squared x minus 1. And so I want to know, whoops. I want to know what my cosecant squared x minus 1 is, and that is equal to cotangent. So that's your answer right there, cotangent squared x. Oh, and I guess I skipped letter D. I'm sorry. I zoomed in too much. Okay. So on letter D, cotangent x, couple of ways you could write it. You could write it as 1 over tangent x, or you could also have written it as cosine x over sine x. Okay, those are both equivalent to that. Okay, cosine x sine x, that is going to be cotangent x. 1 over cosine squared x minus 1. So again, we're going to be using our, let me just zoom in. We're using our Pythagorean identity, the cosine squared x minus, plus sine squared x equals 1. And I need to get this to the other side. So that's going to give me sine squared x equals 1 minus cosine squared x. So this is equal to sine squared x. That's your answer. On H, again, if we look up at these, okay, I'm going to be looking at the 1 plus cotangent squared x plus is equal to cosecant squared x, okay? So 1 plus cotangent squared x is equal to cosecant squared x. And I want my cosecant squared x with my tan, so I'm going to take this to the other side. So this is going to equal 1. Cosecant squared x minus cotangent squared x is a 1. That's your answer, 1. Okay, so on this one, what you want to do on this one, when you see a 2 sine x cosine x, I added on here, let me scroll down, some of the properties onto this back page here, just so I have a reference. So the one we're going to look at is double angle, okay? So we are going to be looking at this one right here. That 2 sine A is equal to, sine of 2A, sorry, is equal to 2 sine A cosine A. That's the one I'm going to use. So when I get back up here, on this one, I am going to rewrite this as sine of 2x equals -1. And so I want to figure out where my sine is equal to a -1 from 0 to 2 pi. And that's going to be down here at 3 pi halves, because that point is 0, -1. So 2x is equal to 3 pi halves. I'm going to divide by 2. When I divide by 2, this becomes 3 pi fourths. And that's your answer, because we want from 0 to 2 pi. On number 3, so on this one, I notice I have a cosine x and then a sine squared x. I am going to rewrite sine squared x. So what I'm going to be thinking of is that Pythagorean identity, sine squared x plus cosine squared x equals 1. And in particular, I'm going to be dealing with sine squared x is equal to 1 minus cosine squared x. That's what I'm going to put in place of this. So I am going to have cosine x plus 2 equals 2 times 1 minus cosine squared x. So I get cosine x plus 2 is equal to 2 minus 2 cosine squared x. I'm going to get everything on one side, 0 on the other. I don't like my cosine squared to be negative, so I'm going to bring it over to the left-hand side. So I'm going to have a 2 cosine squared x plus a cosine x. I'm going to minus 2 from both sides, which means those 2's are going to cancel out, and I get this. Now I'm going to factor this. I'm going to factor out a cosine x, and I have 2 cosine x plus 1 equals 0. So I'm going to have 2 situations I'm going to be working out. One of them is going to be what makes my cosine x equal 0. The other one is going to be here, if I set that equal to 0, that's going to be cosine x is equal to a -1/2. And we're doing this for all x. So, well, my cosine x is 0 at here, which is pi halves, and here, which is 3 pi halves. Now, we would go plus or minus 2 pi n or 2 pi k, but we want to pay attention. The distance from here to here is the same as the distance from here to here. They're pi away. So I can, instead of writing it as two separate angles plus or minus 2 pi n. I can write this as pi halves plus or minus pi n. So that's going to be one set of answers. And then for my cosine being a negative 1/2, cosine is your x. So I want basically short comma long. Short, long, so it's going to put me here. And also short, long is going to put me here because that's going to be a negative. And so this is going to be 2 pi thirds. And this one's going to be 4 pi thirds. And again, if I'm looking at the distance from one to the other, the distance from here to here is not the same as the distance from here to here. So these cannot be written in terms of each other. Okay, so I am going to write out two separate answers. I'm going to have 2 pi thirds plus or minus 2 pi n. That's 1. And I'm going to have 4 pi thirds plus or minus 2 pi n. And that's going to be my other set. Okay. Second number 3. So this one we're going from 0 to 2 pi. I'm going to factor this. It's basically almost like this. Let me just rewrite it. Think of it as m squared plus 2m minus 3 equals 0, where I can factor it. Okay, so I'm going to factor this. And so what I'm going to have is I'm going to have a cosine x. My minus 3 needs to add to a 2 and multiply to a negative 3. So a positive 3 and a negative 1. So I'm going to have cosine x equals negative 3. And I'm going to have cosine x equals 1. Cosine is between negative 1 and 1. So this is not going to be an answer. Okay, it's not going to be possible. This one here, where is my cosine equal to a 1? So that would be at 1 comma 0. So that would be 0. And again at 2 pi, but they don't want us to include 2 pi. So my answer for this is just going to be 0. Number 4. Okay, again, this is from 0 to 2 pi. So I have a 2x and I have a sine x. So you want to be careful with that. So I'm going to use that sine 2x formula. Let me just jot it here. Sine 2x is equal to 2 sine x cosine x. So that's one of the double angle formulas. So I am going to basically, in place of this, write this. So I'm going to get 2 sine x cosine x is equal to sine x. I'm going to get everything on one side, 0 on the other. So I'm going to have 2 sine x cosine x minus sine x equals 0. I like it to equal 0 so I can factor. Okay. So now I have a sine x here and I have a sine x here. So I can factor out a sine x. And I'm going to be left with a 2 cosine x minus 1 equals 0. So for my sine x, I'm basically going to be trying to figure out where my sine x is 0. Okay, and my sine is my y. So my y is 0 up here at pi halves. Sorry, no, it's not. Apologize. I'm looking for my y. My sine is 0 here at 0, at pi, and then again at 2 pi, but it doesn't want us to include 2 pi. So I'm going to have x is equal to 0 and x is equal to pi. Okay. Now for my cosine, if I set this equal, cosine x, I'm going to add 1, divide by 2. So where's my cosine equal to a 1/2? So that's going to be short comma long because I want my cosine to be my cosine is my x. Okay, so short, long. Short, long. It's going to put me here at pi thirds and down here at 5 pi thirds. So then I also have pi thirds and 5 pi thirds as answers. So I have those four answers from 0 to 2 pi. Okay, so these ones I'm going to be trying to prove or verify that these are equal. So I am going to be keeping that. I'm going to be trying to get a cosecant x. Now, cosecant is 1 over sine. I think the first thing I'm going to do is I'm going to rewrite that. So cotangent is cosine x over sine x. And then I still have times cosine x plus sine x. And again, we're trying to get cosecant x. Okay. So now the next thing I'm going to do is I'm going to write this as a fraction. So that's going to be cosine squared x over sine x plus sine x equals cosecant x. Next thing I'm going to do is get a common denominator. So this is really over 1. So what that means is I'm going to multiply the top and the bottom by sine x. Okay. So I'm going to have cosine squared x over sine x. And I am going to multiply top and bottom of this by sine x. So I'm going to get sine squared x on top. On bottom, I multiply it by sine x, I get sine x. Reason I did this was I was trying to get a common denominator. So now both of these are going to be over sine x. So I can write cosine squared x plus sine squared x over sine x. And remember this right here, this is really a 1. So that's going to be 1 over sine x. And that is going to be a cosecant x. So I get cosecant x equals cosecant x. So remember, I was trying to get cosecant x. And so I got that on both sides. Okay. So looking at number 6, okay, verify, but again, it's the same idea. What our goal is to keep this sine x. So what I am going to do is I'm going to think of this as being over 1, and I'm going to get a common denominator. So that 1 is really going to be a 1 plus sine x over 1 plus sine x. That's a 1. Minus cosine squared x over 1 plus sine x. So again, the one thing I just did was I rewrote this 1 like this. Okay. And our goal is to get a sine x. So now they have a common denominator, 1 plus sine x. So I have, when I put all that together, I have a 1 plus sine x minus cosine squared x. Okay. Now this part right here, let me highlight it. This 1 and minus cosine squared x. That, remember, let me just jot it. I'll put it up here. Remember that sine squared x plus cosine squared x equals 1. So if I was to subtract cosine squared x from both sides, I would get sine x. So that I highlighted in green is just a sine squared x. Okay. Plus my sine x over 1 plus sine x. And then I have a sine x in both terms. So I can factor out a sine x, and I'm going to be left with sine x plus 1 over basically sine x plus 1. Okay, those are the same. And so what's going to happen is this 1 plus sine x and this 1 plus sine x are going to cancel out. And I get sine x on this side. And remember, the other side was equal sine x. So there you go. Number 7. Okay, so on a problem like this, sometimes I change my tangents and cotangents to sines and cosines, but I noticed that I still have tangents and cotangents over here, but my tangents now have y, where on the other side they were x, and my cotangents now have x, where on the other side they had y. Okay, so what I'm going to do is I'm going to rewrite all of my tangent x's in terms of a cotangent. So that's going to be 1 over cotangent x. Okay. I'm going to do all of my cotangent y's as a tangent. Okay, so that's going to give me 1 over tangent y. And on bottom, I'm going to have the same idea. So I'm going to have 1 over cotangent x, but these aren't adding this time. These are multiplying. Okay. And so my cotangent y is going to be 1 over tangent y. So what I am going to do is I'm going to try to get rid of those denominators. So I am going to multiply everything on top and everything on bottom. Now on top I have 2 terms because of the plus. On bottom I have 1 term because it's the multiply. But I'm going to multiply everything by cotan x tan y, cotan x tan y, cotan x tan y. So here I'm going to have this cotangent x and cotangent x cancel, and I get a tan y, which is what I want. Over here, my tan y and my tan y cancel, and I have a plus cotangent x, which is again something I want. Now on bottom, because this is a times, not a plus, this is a single term, this cotangent, this tan y, and this tan y, I get over 1. And remember, I'm trying to get tan y plus cotan x. Well, when it's over 1, I'm going to get tan y plus cotan x equals tan y plus cotan x. There you go. Okay, number 8. Okay, so I need a cosecant squared x. Okay, so looking at this, I'm going to get common denominator. And so I am going to multiply everything here. This first fraction by a 1 plus cosine x, 1 plus cosine x. This other side, it's missing it would need a 1 minus cosine x, 1 minus cosine x. Now, let me highlight this. this is what I'm trying to find. That's not changing. Okay, that I have still. This side is still the 2 cosecant squared x, not changing that. Okay, so now if I'm looking at the pink, I'm going to have a 1 plus cosine x over, and the second one's going to be a 1 minus cosine x. And again, all of this is over. And both fractions are going to have a 1 plus cosine x, 1 minus cosine x. Now on top, I get a 2 because of the 1 plus 1, the cosine x cancels out. And a 1 plus cosine x, let me highlight it, this 1 plus cosine x times this 1 minus cosine x. That is a difference of 2 squares. That is a 1 minus cosine squared x. And again, this is what we're trying to get. Okay, now a 1 minus cosine squared x, let me just kind of jot over here real quick. Remember, sine, I'm going to make this smaller print. Sine squared x plus cosine squared x equals 1. So if I was to subtract my cosine squared x, you see I'm going to get a sine squared x. So this right here is just sine squared x. So I am going to have 2 over sine squared x equals 2 cosecant squared x. Now a 2 over sine squared x, 1 over sine squared x is a cosecant squared. So this becomes 2 cosecant squared x equals 2 cosecant squared x. There you go. On number 9, okay, I'm going to be using my double angle formulas for 2 cosine A. So I've got all of these. I've got one where I need to know my sine squared and my cosine squared. I have one where I need to know my cosine squared, and I have one that I need to know my sine squared. So I think I'm going to be using this one here because I think I know my sine, but let me just double check it. So that's 1 minus 2 sine squared x. Okay. So yes, I do know my sine. Okay. So just a quick note, I am in quadrant 2. Okay. I do have that this is angle A. Opposite is 5, hypotenuse is 3. This would be a -12 in terms of this. But I do know that cosine 2A is equal to 1 minus 2 sine squared A from those formulas. So I know that I'm going to have 1 minus 2 times 25 over 169. I am squaring this. And so that's going to be 1 minus 50 over 169. And if I do that math, that's going to be a 119 over 169. And that is my answer. That's what my cosine of 2A is going to be. So this one here, rewrite one trig function, rewrite as one trig function of one angle. So when I have sine of one angle, cosine of another angle, minus cosine of that first angle times sine of the second angle, I'm thinking about the sum and difference formulas here. And it was a minus, so I'm thinking about this. So I basically am going to take the two angles, subtract them, and it's going to be sine of that. That's the one I'm using. So I'm going to have sine of pi sevenths minus 2 pi thirds. And when I do that math, let's see, pi sevenths, I'm going to times top and bottom by 3. 2 pi thirds, I'm going to times top and bottom by 7. So I'm going to get 3 pi 21st minus 14 pi 21st. I get negative 11 pi 21st. And that's your answer. We wanted you just to write it as a single trig function of a single angle. And that's that.